Good morning and afternoon, everyone. Welcome to our weekly Friday Fast Track Hangout with Autodesk. This week I'm super excited. We have Mike Prom. He's our Fusion 360 product manager, a mechanical designer, and a Fusion Jedi Master is going to be with us today to give us a deep dive into sheet metal, the new functionality in Fusion 360 this month. Thanks for being with us today, Mike.
Happy to be here, Wayne.
Awesome. Super excited for today. So before we jump into it, guys, I want to talk to you guys a little bit about our webinars, and I know a lot of you have joined us and there's some new users out there. We want to keep this as a good conversation. As we do the webinars, it's not always one-sided. We'd like to hear from you guys, and I know that we have some of our elites and our expert users and power users out there with us who also like to join the conversation and bring some of this information, their knowledge in machining and their knowledge in designing into this conversation. If you guys have any questions, please feel free. You can ask in the questions panel of our GoToWebinar, and please feel free to jump into the conversation. So as we go through, I want to start to talk to you guys a little bit more about our Autodesk University that's coming up this November, the 14th through 16th. And we're going to have a very CAM heavy and a manufacturing heavy conversations going, as well as keynotes, hands-on classes. On the first day you'll be able to design your own PC speaker, or shall I say PCB board that goes inside of a speaker that you can plug into your iPhone or your Droid phone, that you'll be able to walk away with that product. You're going to learn how to design it inside of Fusion, 3D print, and machine. And those hands-on classes will be happening all week. And as you can see, throughout the full track of CAM classes, we have our experts as well as Autodesk experts and power users will be there to teach classes as well. And it's a great chance for you guys to network and get to know some of the other users out there, power users and people who are in our community making some awesome stuff. So it's a great opportunity to get out and meet people and learn more about Fusion and learn about machining. So just a sneak peek, we want to give you, or sneak peek, to give you an idea of what's happening in our product innovation platform. That's the speaker that you guys would be making when you join up, and get a good idea of how to work with our Fusion 360 interfaces. So some of the classes that we have a certificate series, and some of these names you may recognize. CJ Abraham is on our development team, a product manager, as well as Angelo Juras. Kevin Lee and Kevin Ellingson on our partner team are power users to teach classes and get you guys started with turning and 2D CAM. And also Derek Goodwin, who's our partner out there in California working with our Haas HFO teams in Selway. So here's some of the speakers, some of the names you guys recognize each week. Some of the people you see in our forums answering questions and sharing their knowledge will be teaching classes this year at AU. I think we've had almost everybody here in our webinars, where Rob Lockwood, John Saunders will be again with us this year, Seth Mador, Lawrence Winshank. You see him as a power user in our forums as well. Amish from SS CAD Cam. If you follow on Instagram, you recognize a lot of these guys. Al Watmu, he's with us today, and he's going to be there as well. Renee, our software architect. Marty Deans is awesome, makes a lot of those training videos and adoption videos, as well as Tim Paul, who's a master machinist. And we're so fortunate to have this team with us at Autodesk. And Lars Christensen, every week he outputs, or he does a weekly webinar with Lars, and every day you see on Instagram he adds those quick tips. So an amazing group of people that you get to work with and learn from and network with. So that's at AU this year. So I'd like to get into, and actually let's jump right in with Mike and to get started on our deep dive inside of Fusion. And to look at some of the sheet metal functionality. So I'm going to hand it over to you, Mike.
Thanks, Wayne.
You got it.
For those of you that don't know me, like Wayne said, Mike Prom, I'm a Fusion PM focusing on modeling. Today I'm excited to show you some of the new sheet metal functionality that came out at the beginning of August. So today we're just going to go over some of the features, do some live workflow demonstrations. Wayne's going to help me with the design to manufacturing going into the CAM. Start off, the sheet metal, we want it to be simple, easy to use, and done in a way that will save you time when you're designing. The goal of the rules is to make them standard and reusable, so you're not entering in information every time you use it. And the same for Flange. So based off of your selection or sketch, which you'll see, we invoke different Flange commands behind the scenes. To start off, we talk about the sheet metal rules. These rules are based off of other CAD tools that we have, so they're standards in industries. These are, if you've used other CAD tools, all the things that you're looking for are there. So we have our material, thickness, K-factor, gaps, bend conditions, corner conditions. There's a little pencil to edit, make new, and then copy to library. And the goal again is to have you use the library as a guidelines to get started, customize them yourself, and then reuse them over and over. I have a couple of just quick gifs here to talk about it, but then I'll demonstrate them live. Based off of the selection using the one Flange tool, we invoke different Flange commands. So in this case, if I have a closed profile sketch and I select it with the Flange tool, it will automatically create a base flange. As you can see with this animation, the same goes for an edge flange. So reusing the tool allows me to first close profile, select flange, it will create the base flange, and then if I do it again by selecting the edge, it's going to invoke an edge command. Very simple for those of you that are new, easy to learn. For those of you that are experienced, this will hopefully allow you to speed up your design workflows. When it comes to contour flange, so this is the open profile sketch, we have a couple different things. First, you're going to see if I select the sketch, I'm able to make a contour, and then if I select an edge, it will actually allow me to join the contour. So again, I'll go through and demonstrate this live, but just want to give you an idea of how the one button works. In the process of creating your flange, when you have multiple flanges that intersect, we have built-in mitering, which will create a miter at the joints where they would otherwise overlap. Unfold and refold is our solution to cutting cross bends. So in many cases, when you create a design, you may want to have a cut that actually goes over multiple flanges. So in order to do this properly and have your cuts normal to, we allow you to unfold, select the edges, create your sketch, cut it, and refold. Flat pattern is our solution for manufacturing. Wayne's going to do a demonstration after I do my live demonstration, which shows you the process to take your design and flatten it. So this flattening will take into account the K-factor for the stretching material. From there, you'll be able to create your water, laser, plasma tool pass for manufacturing. There's some really nice tricks and tips that we have based off of other traditional fusion workflows where you can replace the face or an edge of a flange, the edge width, so by changing your selections in your drop-down for flange, which you'll see, you can change the width of the flange. You can use other tools like extrude, press, pull, and move, combine in order to make your designs interactive, and join based off of selecting the edge or not selecting the edge. With that, we'll jump into it. If there isn't any questions so far, Wayne. Okay. So first thing we're going to take a look. No questions. Perfect. Thanks, Al. First thing we're going to do is take a look at this router head, and I need to make a cover for this. Simply just create a sketch and project it. I'm going to isolate this just to make it a little easier for us to see. Like switch from my modeling tab. So in August, again, we added this sheet metal environment. Here I can just use my flange tool to select a closed profile, and this flange command now automatically takes in the thickness from your material and makes your flange or your base flange based off of that. So if I go into my rules, as I mentioned earlier, we have a library of rules that I pre-created. The idea behind this is for you to have some ideas of where to get started, but we have intended for you to customize yourself. I have a couple different rules that are in this design already. In this case, I'm using the aluminum millimeter. So if I edit this, I can change it from 2 to 6, hit save, and the material automatically updates. This is something I want to save back to the library. I can right-click on that, say copy to library. I can edit it, or I can edit it right here as well. So let's change it one more time and make it 10. Hit save, makes it thicker, so you can see as it updates. I can then continue on. So I selected the close profile to do a base flange. Now I can select the edge of this design. So I can take this and drag it to create my flange. This is what we saw in the little GIF there, so I can change the angle. I can drag with manipulators, and I can also type in numbers when needed. Now that was the closed contour, the closed profile of the base flange, and then also selecting the edge. If you look at this design here, and I'm thinking about how I make this cover, I can simply just start off with an open contour sketch. So in this case, I have this cover. Again, I'm going to activate it and isolate it. This allows me to focus on the timeline just for the model that I'm working on. Using that same tool, when I select flange, it allows me to create a contour flange. So again, the intention behind this is just to make it very simple and easy to use. And those of you that are expert designers, this will just speed up your process, where I could right-click, drag up to repeat the flange and continue making that design. As I mentioned earlier, it's very critical to have your cuts that go across bends many times be done in the flattened stage. So we have unfold and fold. In this case, I could select the edges individually to unfold it, or I can select all bends. One thing to note is that when you're in an unfolded stage, if I select unfold again, it's going to bring up the menu to either edit my unfold or cancel. We don't allow you to go inside unfold, inside of the unfold. So if I hit edit, I could deselect any of these if I didn't want all of the bends to be included. Or if I only had selected a couple of them to begin with, I could add additional flanges to unfold. Now in this case, I'm going to create a sketch. And I'm going to select my plane. Very critical to acknowledge where your bends are. So in this case, if I don't want that angle to go across the bend, I can start on the left side and on the right side and then finish on the left side. That way that line is not crossing across the bend. My bends will have a nice flat contour. Utilizing some of my constraints, I can reduce the amount of mates, so dimensions that I need to add. Make this fully constrained. I'm also going to add a couple more on the bottom here as well. Again, I'm paying attention to where I'm starting and ending this, making sure that my sketches don't cross over those bend lines if I don't want them to be at an angle. Okay, I've created some sketches, and I can simply just invoke my extrude command by using E, or I can go up into my panel and select them as well. In this case, we're going with a cut, and selecting OK, and then I can refold. Before I do, I just want to make one comment. While I'm in my unfolded stage, we do not allow you to make additional flanges. The reason for this is you can get into situations that are not ideal for manufacturing. So if I select flange right now, it'll give me a message that says you must refold. If I hit refold, it's the same as selecting this button over here. Now I've created my design. I can finish this design by adding another flange along the bottom. I can either drag or type in an angle. You can see here, maybe that was a close guess. There's a lot of value having the ability to manipulate in context. Now, as far as length, I just know I want to stop here, so I'm just going to reference that point, select OK. There's a couple different approaches you could take when changing this flange to match this edge. One thing that I really like about Fusion is I can reuse all the tools and abilities that they have. So in this case, rather than measuring, figuring out what everything is, I can just select that edge, and I can do a join, change this distance to object, pick that face. I can actually add an offset. Looks like my flange is intersecting, so let me just edit that real quick. Another thing I should mention while I'm here is we can change the flange width. So right now it's a drop down. You'll soon see some enhancements where these arrows will appear on your last flange by default. This gives me the ability to drag. I could also type in here if I want numerical values as well. And change my offset. So I have an offset option, full edge. I can do symmetry. There'll be a width as well. So select OK. Made this a little smaller, but you'll still get the same idea, where if I select this edge to extrude, and change this again from cut to join. My favorite things is our extrude has a built-in offset, so I can keep my gaps.
That is awesome.
And this will allow me to...
That's super awesome. So, and that flexibility built into the tool is just amazing.
Yeah, it's very powerful. That you don't have to get there down, measure and figure out what the distance is, and you could add a sketch onto this and project that extruded, unfold and refold. These are just some nice features that are built in. The one thing is that it does make this at an angle depending on how you have this. We are adding cut normal, so when you add or remove material, it'll keep it normal for the face, and that will reduce any additional work that you have to do. We saw earlier in the glyphs there were some join opportunities, and if I look at this design and how easy it would be to make a side panel, it's as simple as really just a sketch. In this case, I pre-created a sketch, and the concern I had was making sure that these ball screws have enough clearance. So let me get in and edit this sketch. Let me see if it'll let me edit. There we go. as you can see, there's a good amount of parts in this design.
So you're able to sketch, but you don't have to be in the sheet metal environment. You can just model in your model environment and sketch it up, and then switch over to sheet metal to be able to get a sheet metal part, right?
That's correct. Yeah, let me maybe just, since you have the idea of how this would work in the context of the model, let me set myself to mute that. And let me do this. Speed this up a second. So
Cool, and I think it's always been one of the more awesome features about Fusion is that you're able to design from top down and not only bottom up, where you can design in the assembly environment and be able to have your parts, you can see it, how they would, either whether it's interfering or how they would mount together, and you can do that right inside the environment, and switching over to sheet metal to now be able to make that a very quick sheet metal part is just awesome.
I agree. So let's think about that same design. So I'll just freehand sketch it so you can get an idea of how it's sketched from scratch. So if my origin is where that ball screw was, I can simply just create a contour sketch as we've seen before. Now when I'm creating my flange, I have some options. I could do it in one direction, or I can make it symmetrical. In this case, if I had the design like the same way, if I'm doing it in the design, I could select the edge. That's where I could do some things like offset face. Now, the reason why I wanted to focus on this is because I need a little stiffening along the bottom. So I can create a sketch on my edge to create a hem. And I could just do a straight hem. I could do something with maybe a little more shape to it. So simply just creating my flange tool again and selecting the edge, we'll join those two together to create a hem. Now, one thing here is that the sketch isn't touching, so I can only do it along one edge. If I change the sketch, excuse me, to be able to connect with that side, what that allows me to do is when I select my flange now, if I hold down my command or control, the Mac or PC, I can select multiple edges. So this is a very powerful tool to be able to join. Just allows you to kind of focus on your design and make it fit. Now, once I've completed my design, maybe I'll make this a little bit shorter. All these are, parametric, so I can come back in, I can edit my sketch, maybe make it a little bit bigger this way. You can see that my model automatically updates. Also, since that sketch was based off the end, if I change, it all parametrically updates as well. We've seen the unfold fold for cutting cross bends. I'm going to show it one more time. I think this will help with understanding when I create a circle. So if I create a circle, and cut it, what you're going to see is that it's a perfect circle when it's unfolded. But when I refold it, it follows or keeps true to what it was when it's flat. Versus if I create a circle while it's bent and go across a bend line, what we'll see is it's a perfect circle when it's bent. But if I flatten this out, it becomes more of an egg shape. So just want to show the value of cutting across bends and the workflow to use it. The last one here is flatten. So I'm going to do this to make a drawing, and then I want to talk about collaborating with Wayne. So if I pick a face for my reference, I now have a flat pattern design. Save this. And what this will allow me to do is I can create a drawing from that flat pattern. Now I was in flat pattern, so I pick flat pattern. You can also do bent. So imagine you have a drawing. I can do the bend. I could add sheets to have bent on one, flatten another, or I could just have one sheet and have both the flat and the bent. So you can see I have my options between folded and flat. I can pick folded. Pick an ISO view. Maybe make this a little larger. So I've done my design, I've created my flat pattern. Let's talk about collaboration. So earlier I was working on this router. I now want to hand it over to Wayne, so I picked one of my front covers. I can simply just save it. And then since we're using the same data panel or in the same project, Wayne can simply just open up that file and work on his cutting.
Awesome.
So Wayne, I did it earlier before I restarted this. Could you just go into your data panel and then show that you can now open the file that I saved and then work on your CAM?
Absolutely. Very cool. It's pretty awesome walking through and seeing what we can do in sheet metal. And I'm going to show the side over here. I'm going to take control real quick, Mike, and I'm going to take the screen and I'll show you guys what we have. Cool. You guys should be able to see my screen now. All right, Mike, is it looking good?
Yep, we can see your screen.
Awesome.
It looks looking great, and I can see that you have a different data panel, but since we share the project, you have access to the same file.
Exactly. And so as we're working and we're collaborating, and I'm on a different part of the world. Right now I'm in Denver, and Mike's in Portland. And so we're able to share directly over the cloud. As he's working on this project, he can send me some notes. If I expand this down, you notice I have this refresh up here because we were working on this earlier. And if I refresh, I can see the latest data sets, the plat that Mike was just working on, and some of the changes in the project. Of course, I can always go back into this project and take a look. If I expand down, I can see the version history here as well. So as he's working on it, and he's asking me to take a look and see if we can make it, and I would work with the team at Pier 9 in San Francisco to be able to cut a part like this on the OMAX machine. So I'm going to open it up from here in the data panel. So I'm going to right-click and go to Open. And again, this is a panel that Mike was just working on. And this is one, I think he made some changes. We'll go back and take a look. But I'm able to see the panel. To be able to make it, he saved it earlier with a flat pattern. And so if I go and take a look at the part in the CAM side, so I can see all the sketches and the details on the modeling side. So if I bring it over to the CAM, so I'm going to go to the CAM workspace. Right now it would be kind of tough to cut it in the format that it's at, but he saved it with a flat pattern. So if I expand down in this environment where the model environment is, I can see this flat pattern, and I can turn that on just same way that Mike did for the drawings. So we have the exact same part that would be in the drawing that we can use to make the part. So I'm going to orient it in CAM. So I'm going to do my setup real quick. So I'm going to go up to Setup, and let me flip it over. So I'm going to set this up as if we're going to make it on the OMAX machine at Pier 9. So I probably would position it. I can set up the stock and have a piece of sheet metal that I want to put on the OMAX machine. I can go in here and change real quick the Z-axis, flip it over. I can easily just select off the panel to be able to flip that over if I want to position it. Look at it at the best way or the most optimum way to position it in the machine. And if I have other parts, I can easily put those together on a sheet. And so it gives you flexibility in being able to work with that in the flat pattern. So what I want to do is I want to set it up with a box point. I'm going to use the top of the sheet. So I'm going to select that point right there on the sheet. and then I have it positioned with the X, Y, and Z and where I want to see it in the machine. So now if I step over to the stock size, I'm going to cut it on the sheet. So I'm going to work on a fixed size box. And sometimes it's a good idea to already have a sheet set up that matches the way you're going to work inside of your machine. In this case, I would have a template of a sheet already on top of the bed inside of the OMAX machine, and I just have to bring this part in and make it a component inside of that assembly. But in this case, I'm just going to walk through with you on how you would set up a sheet like this. If I have a 36 by 36 inch sheet, I can easily plug that in to the fixed box dimensions, something like this, and then I can position the part inside of that boundary. If I wanted to say I want to have it off the left side and I can give it an offset of say 3/4 of an inch, I can easily do that. And the same thing for the depth. So if I wanted to have it off the positive Y side, also 3/4 of an inch, I'm actually going to bring it back here so it'll be closer to my origin. So I'm going to make that a negative Y. So I can easily position the part where I want inside of the sheet. And of course I can also do this on the height as well. So I can give it the thickness. I can tell it whether we have an offset or not, or I can choose 0 offset. So it's going to be right in the center or positioned right inside of the sheet right there quickly and easily. So there's a lot of flexibility in Fusion, especially in the CAM interface, to be able to set your part exactly the way you want to see it on the machine. So this is important to get this setup part in the beginning correct. So we have it set up the way we want to see it. I'm ready to machine it, so I'm going to say, okay, notice in my setup, it recognized that we're doing a cutting operation. I didn't have to select it, change it from milling or turning, which, by the way, is exactly the same workflow. No matter which set of toolpaths you're working on, you can work the same exact way. In this case, it recognized that we're doing a flat pattern, a sheet metal flat pattern, and it made it a cutting setup automatically. So I'm going to change, I'm going to say OK. Now we're ready to start to cut this part out on the waterjet. So I'm going to go up to my cutting profile, and working from left to right, that same workflow that we're used to. I'm going to go from my tool to geometry, my heights, passes, and linking. So I'm going to select the tool out of a library, and it's a good idea to create tools that match the way that you work with your machine. So in this case, we're working on the OMAX machine. We have some tools set up that we can work on that machine. So I'm going to grab the 1 millimeter waterjet. And I think they work in inches there too, but we can also set up and filter and create a tool. I can right-click, copy that tool, paste it, and turn it into an inch based tool just by simply going here, change it to inches, and I think this is 0.042 is our kerf width, and we can put the nozzle clearance really quickly and create a waterjet tool with our speeds, feeds, things like this in our cutter, and OK, now we just added a new tool to the library that we can work with. Okay, so I'm going to select that tool. The next thing I'm going to do is go through and select the geometry. And the cool thing is selecting a contour. If you have multiple contours on the sheet that you want to cut, you can easily select the same plane faces. It'll grab all those faces. In this case, we have this one face. I just select it, and it knows that's the area we want to cut. It gave us the chain, and I get to choose whether I want to do a start inside or start outside. If I want to change, if I'm cutting holes inside of it, I can easily change how those loops and the side that I'm cutting on. So this one I'm going to change to start outside. If you wanted to add tabs, you can do that and easily add the width of the tabs by distance. You can also have the tab distance in between them. This case, I'm not going to use the tabs. We're going to cut it out as it is. And again, I can change the heights as we're used to inside of our cam and passes really quickly. So we're going to leave it the way it is. I'm going to say OK. And now we have a path that we can cut on the OMAX waterjet. So I want to take a look and see what that's going to look like. So while I have it highlighted, I'm going to go up to Simulate. And I can simulate as if I'm already on the machine and cutting through. You can see the path that it's going to take to cut it out. Okay, now I want to get some code that we can send over to the OMAX to be able to cut it out. So I'm going to close this out while I have that highlighted for that 2D profile. So I'm going to go up to Post Process. And in our generic post, we do have post for cutting. You can filter this down on type. You can filter milling post. You can filter down to cutting post, and it filters the library down. If you don't see your machine's post here, and we do have posts that are available, I would check here. Go to search for our post on our online library, and search. You can search by vendor for your post. If it's a cutting post, you can go and look by any time it's been updated. You can also look here and filter down for waterjet and plasma and laser. And you can see we have posts up here, and you can see that they're updated online here pretty often. So you can look here for your post. We also do have our posts in our forum, where we have a team of people, experts out there who write posts, work with posts. Our partners are out there creating posts for machines, and you can always search there as well for your post for your machine. So again, it's nice to have that right here, a link right inside of our post library or a post interface that you can look for a post. So in this case, we're working on the OMAX, and it did come with the post inside of Fusion. So I can select the OMAX waterjet, and I'm going to give it a number for the machine. So this will be program number 1, and I can post out. I have some switches that I can turn on and turn off right here. So I'm going to post out the code. I think I did an OMAX one earlier, and this is the code specific that you can run for the OMAX. I think there was a point we were talking with Al that our developers are just amazing that they're able to get in to make post. Now, this isn't your usual G code, specific language that we can interface with the OMAX to be able to cut parts like this out, but it's available, and here we were able to run that and send it over to the OMAX machine. Cool. So we got some code out, and of course if we go back and make any changes, and if I would send this, I would save it, get the code out, we can run that part. If Mike is looking for a prototype, we can run it. He can get in touch with the guys at Pier 9 and be able to bend this part up and have a prototype within just a few minutes of being able to make the part. So that's the CAM side of working with sheet metal, and I would go back and I'd make some comments. I can easily go back in here, and I can make a comment to Mike if I have him in my list here. I think I have Mike in here. So if I didn't, there he is. I could just say, Mike, added the toolpath, to cut the prototype, to cut the panel. And then really quick, if I can spell, I can even, I think I clicked the wrong thing, but anyway, I can send him a quick email. All done, Mike. And then if I send it to him, if I post that, it's part of this project, so he's able to see that no matter what device he's on. He can see it on his iPhone. If he has an iPhone, he's able to see it on his Mac. I know he's working on a Mac today, and he's able to communicate directly. He could take a look and see that we have a toolpath on this part, and it's a great way to communicate, and a great collaboration tool to work inside of Fusion really quickly and easily. All right, so that's the latest.
I'll add one more comment.
Sure.
I was going to add one more comment to that, Wayne, too. You have a great community here with all the CAM users, and I'm not sure how many people have tried this before, but if you're ever struggling on something, you can always make a project and put files into there, and then share it with us as well. So that's one easy way, just the same as Wayne and I have, shared this file together. It's another easy way to get help with files as well.
Absolutely. Thanks, Mike. And that's true. I mean, we use these tools every day, and just like you're working with Fusion to collaborate with your customers or partners, or even collaborate with your other people on your team. We do the same thing. We provide help. We're able to get into the project when you share them with us, and it's easy to add people. So if I want to, Mike added some people here. As long as I have access to it, I can invite other people as well. Super easy. Just add them here and invite them to your project. So you can invite us as well. If you ever need somebody to give a second eyes on your project, or to see if something is set up the way you normally do it, if you just ever need any help, you can feel free to invite us to a project, and we can share the same way. And that's one of the greatest things about Fusion, is that ability to collaborate directly using the tool. So with that, guys, I think Mike, do you want to add anything, any other information for for what we did here in collaboration?
I think our goal is just kind of give you guys some exposure to sheet metal, give you an opportunity to ask any questions, see the workflow of making drawings and how to utilize it in CAM. I don't see any questions in the chat here, but if there are follow-up questions, Wayne had my email in the beginning. I'm sure with the follow-up he can give you my email as well. Happy to answer any questions that you had. Understand that that was our first release. We're continuing to make advances in sheet metal. We're very excited and we're looking for feedback.
So for any of the users on with us today, have you guys, yes, this is going to be recorded, Dan. We'll make sure we record it and we'll put it on our YouTube channel in Autodesk HSM. If you guys have any questions, like now is a great time to ask. Mike's an expert with Fusion and he's a great person to ping questions off of, so this is a good opportunity for you guys. Now if you've tried working with sheet metal, maybe even brought it into CAM, if you've run into any roadblocks or if there's anything you'd like to share, this is a great forum to do that. So please feel free, ask some questions now and we'll definitely get an answer for you guys. Oh, that's a good question.
Everyone just...
So Dan, he's asking Mike if how about nesting? Will we have nesting available?
So what we're working on right now is the ability to insert the flat pattern only into a new design, which will give us manual nesting. We have another group that's working on technology that we own and some solvers for it. So it's part of our strategy. I want to be very clear when we're talking nesting, we're not talking full ERP integration type nesting, but we're talking more of a Sigma nest kind of level of nesting. So it is a part of our strategy and our plan. There are groups working on two sides. One is for manually, which will be in the near term, and the other is to have an automate nesting.
And just to add to that, this is Al here, because when we do the nesting, we're looking at it. Yes, sheet metal is a big driver for it, but you just as likely use nesting for flat parts. What I might suggest is in the short term, you can use a plugin that actually one of our guys wrote, Patrick Rainsbury. So if you search the App Store, there's actually a nice little nesting add-in that you can install. In order to nest sheet metal parts, as Mike had mentioned, you will need to have the ability to put this into separate files first.
So here's a link you can get right out of Fusion, a link to the App Store that Al had mentioned. And you can get a link in here and do a quick search for those plugins that you can find for CAM. And see, look, there's the OMAX and Telecam add-in as well.
I don't believe it was listed as a CAM plugin, so just do a search of all of the Fusion ones for Nest.
Okay. Let me just make sure I'm searching them all. Filters, all apps, right? Filter.
You know what? I might need to get Patrick to repost it. I thought he had it up there.
Awesome. Yeah, that would be good because it's a really good, helpful app to have. And so we'll make sure we get the link out to you guys. And when Patrick posts it up, we'll get that info out as well. Cool. So you guys have any other questions for us? Like I said, this is a great opportunity to have a good conversation about, sheet metal and any places that you guys are having any problems or roadblocks or just want to know a little bit more. Please feel free. Well, cool, guys.
Well, Wayne, thanks for your time, and everyone on the call. I appreciate your time as well. If you have anything further, please reach out to me directly.
Awesome, Mike. Thank you so much for being with us, and it's just amazing stuff that's going on in sheet metal inside of Fusion. And we're going to start to see a lot more, I'm sure. Oh, there's also a challenge. I think it's still on, isn't it, Mike?
It wrapped up this week.
Gotcha.
So I think the 30th was the last, but you'll see some of the winners. It's pretty fun to see what people come up with.
Awesome.
But keep an eye on Instagram because that last one was a sheet metal one. There's one final cam challenge before AU, so keep an eye out. Watch Curtis Chan and myself and the Autodesk Instagram channel because the next challenge will be starting soon.
Awesome. Now, is that like we've done in the past where a winner will be able to get a ticket, or shall I say, registered for AU? Is that going to happen again, Al?
Curtis will have to give the details, but
Awesome.
I believe so.
Very cool.
And the cam challenge will be all-encompassing, don't worry. You people in Europe can compete in the cam challenge.
Awesome, guys. So keep an eye out. As Alan said, keep a look on Instagram and see what the challenge details are going to be about and what you can win. And those are always fun. So with that, guys, thanks for joining us. We're a little bit early today. And next week, we're going to have Matt Nichols back with us to do a nice deep dive inside of how to program using the API, to walk you through how to make some apps to automate some of your processes and to work inside of the API inside of Fusion. So guys, join us next Friday on Wednesday, every Wednesday for anyone who's new. Join us for our weekly webinar on Wednesday to go through the basics of turning and the basics of milling. So again, Mike, thank you very much. It's great information. It's always a pleasure to collaborate with you. And Al, thanks for joining us to help with questions and being part of our team and being part of this great community.
My pleasure, Wayne.
No problem. Thanks, George.
Awesome, guys. Thanks again. And we'll talk to you guys this week if you want to join us on Wednesday. If not, we'll see you Friday. Thanks, everyone.